It all started a few years ago. It was the last time we saw him, and it was the start of an adventure.
Brock, I think I found Riemann. You need to get here ASAP. You're on your way? Alright, good.
Are we clear?
Yeah.
Where's he at?
Who?
Riemann.
Riemann? He's up there.
Alright, let's get him. Riemann is a dangerous man. Okay, he can be up with anything. So we need to have the necessary precautions and the necessary firepower. You brought it?
I brought the firepower.
Alright, let's go. Are those them? Are those the big guns?
Yeah.
Alright.
Banana, banana, banana.
You said Riemann's up here?
Yeah, he should be right up the hill.
Alright, let's be careful. This is the first time I've ever explained the question to anybody. And little did I know, this would be the last. So, in order to answer the question, we need Riemann. That's why we're up here. So, what's the question? Estimate the area under the curve of the equation f of x equals x squared. How are you supposed to do that? Well, again, it's Riemann. First step, I have to draw out the graph. Also, it said with the bounds 0 to 3. Forgot to add that. So, what's the first way to do it? You can graph it any way you like. So, the graph is going to look a little something like this. 2, 4, 3, 9. And all we're worried about is this area here and this area here. This area under the curve here. How are we supposed to estimate that? Hopefully Riemann will tell us. There he is, watch out! Get down! Hand it over! We know you have the sum, hand it over!
I will not have these sums.
I'm taking the shot! No! You can't do this! Oh. Alright, Riemann, we can sit here all day, hand your sum over.
Wait. There he is.
No, that's Riemann's son. We need his sum.
Oh.
Alright, Riemann, your last chance, hand your sum over.
You'll never get my sum. Fine. Have it your way.
You can hand me the sum. We got its sum.
Nice.
We got it.
Nice.
Oh my god, we can finally find the answer. What you do is successfully estimate the area under the curve. And there's different subdivisions. So what essentially is going on in Riemann's sum, this is pure genius. You're making rectangles under the curve to find the area. There's 3 types: left Riemann's sum, middle Riemann's sum, and right Riemann's sum. Each of these has different amounts of accuracy and okay. Let's apply this to our question. So originally, this is what we had. We're making rectangles under each curve and finding the area of those rectangles to estimate the total area under the curve. The more subdivisions you have, or rectangles, the more accurate it is. In this case, let's say we have 3 subdivisions. The width is 3, so that means the width of each rectangle is going to be 1. We're going to have 3 rectangles. The height of each rectangle, of the 3 rectangles, would be the y value of the leftmost x point of each rectangle. So for this rectangle, the leftmost x value is 0, and that height is 0. For this rectangle, the leftmost x value is 1, and that height is 1. For this final rectangle, the leftmost value is 2, and that height would be 4. So what you do is you add it all up, add all the areas of the rectangles up. So for this first rectangle, the width is 1, and the height is 0. For this rectangle, the leftmost x value is 1, and that height is 1. For this final rectangle, the leftmost value is 2, and that height would be 4. So what you do is you add it all up, add all the areas of the rectangles up. So for this first rectangle, the width is 1 and the height is 0. So 1 times 0. For this one, the width is 1 and the height is 1. And for this one, the width is 1 and the height is 4. So 0, 1, 4, and that's 5. So the rectangles of the right Riemann sum would look like this. You do here, and they would go over the curve. And the rectangles of the left Riemann sum would be like this. This would be nothing. These would go under the curve. All you do in the middle Riemann sum is the width would still be 1, but the y value, you would take the middle y value. So in this case, you take the y value of 0.5, 1.5, and 2.5, find the y values there, do the rectangle for each of those, and then add them all up. So the y values for the middle Riemann sum would look like this. It goes in the middle, and it's the most accurate, and it's the average of the left and the right Riemann sum. Alright, so we finally found the answer to the area under the curve using Riemann sum. After all these years. We're sorry we had to do this, Reimer. We needed to find the answer.
I have one last thing to tell you. I'm your father.
Oh my God. And that was the end. The end of our journey to find a Riemann sum.